All right, the last 5 problems of this review. Let's go ahead and get started. Number 16, a banking account has an initial investment of $10,000. Well, that's going to be your starting value here. It's gaining 4%, so that's going to be in the parentheses 1 plus R, since that's growth. And 4% is 4 divided by 100 as a decimal, which is 0.04. So it's going to be 10,000, 1 plus 0.04. Set up an exponential equation to the t power. Then use logarithms to solve for the time it will take for the account to have 50,000. So in this case, we want to know when is it going to be. We don't know the t value, but we want to know when is that going to be around $50,000. That's the question you have to solve. That's your equation. So your setup, your a value is going to be $50,000. Okay, so that's what I'm setting it equal to. So if I want to use logarithms, what I'm going to do is I'm going to divide both sides by 10,000. And that's going to be 1.04 to the t power equals 50,000 divided by 10,000. Well, how many times does 50,000 divide? How many times does 10,000 go into 50,000? Should be 5. And you can double check the math on that. That's the equation we're solving. So you do log base 1.04 of 5 equals t. Write it in log form. Remember, the base of the log's down here, the number after the equals is in the log, and then your exponent goes after the equals in the log form. That's what you want to evaluate. So it says about 41.03, which is going to be, which is going to round to 41 years. So that's about how long. I mean, you could also just take 41 and plug it in to see if that gets you around 50,000. This is going to be the closest one to it. All right, last 4 questions. What's the correct simplified logarithm of log of 12 plus log of 2? Well, let's remember what rule that was. So when it's addition, well, let's go back to the properties. So the product property is coming from addition. So that would be log of A times B. So when you have 2 separate logs of the same base with numbers inside, then you can simplify that to 1 log where you times the numbers. So if I'm using that property, then that would be log of 12 plus log of 2. Then that means I'm going to want to multiply 12 and 2 in that log. So that should be log of 24. Now, since these are actual numbers, we can check them. So log of 12 plus log of 2 is 1.38. And the only log that gives me the same number is log of 24. So that's a quick way to check if they're numbers. All right, 18. What's the correct simplified logarithm of 2 log 5? All right, so when you have a number on the outside, in the log, you can actually think of that as log, that's the power property. And that power, that 2, is an exponent of 5. So you can think of that as log of 5 squared, if you want. Basically, that works because you could say 2 log 5 is log 5 plus log 5. It's like double, right? But that would require those two to be multiplied together. Well, there's two of them. 5 times 5 is 25, which is also 5 squared. So that's another way of saying log of 5 squared, or simply log of 25. That's actually going to give you the same thing as 2 log 5. And we can verify that in the calculator. Same number. All right, last one, which doesn't have numbers, so we'll have to do that one by hand. For question 19, this is the division. So when I have log of x over y cubed, I want to break that up. The quotient property would be log of, we'll just do log of a minus log of b. And that's the same thing as saying log of a over b. So since I have it as a division, I can expand it and do log of x. And since that's division, division goes to minus log of y to the third power. But expanding means I need to get rid of that exponent. So I need to bring that out front of this log. So we're going to keep the log of x as is. But that 3 is going to get powered down. And that's going to go out front of the log y. So log of x minus 3 log y will be your expanded form. And question 20. Looks like there's a little glitch in the question. It's not showing the right problem. Oh, there it is. Which function represents exponential decay? Well, decay occurs when the base is less than or between 0 and 1. So if you look at your base, and the base is what's in the parentheses, so 1/2, 2, or 2. Well, the top two have numbers that are between 0 and 1, and the bottom two have numbers that are above 1. So one of these would be the decay. Now, which one is going to show the graph going down as it goes to the right? So decay is going to look like this. Exponential growth goes up as it goes to the right. Decay goes down as it goes to the right. Well, we want the x to be positive. So we're going to graph that. That is a decay problem. That's growth. That's growth. And so is that. So the only one that's going down as it goes to the right is going to be that first one there. So that's going to be exponential decay. So there you have it, folks. Questions 1 through 20. Hope that was helpful. You have until the end of the day Wednesday to make sure that you submit the assessment. I'd like you to get that done. That's on Canvas. You also get unlimited attempts on that as well. But I won't have a video going over those specific ones, but it'll be like these problems. So go back and review these videos or have them loaded while you're working them out, and we'll see you on the other side.